On the bench today we have a rather rare and early sideband radio. This is a Siltronix SSB-23, so model number kind of gives it away. It's a 23 channel radio. But it is a true sideband radio. Radios not too far before this would have been tube type, and they may have called them single sideband, but they transmitted double sideband. So yeah, that was a short period of time until they finally figured out how to do single sideband transmit, and right around that time, was the introduction of solid state heavily into CB radios. So this is one of the first ones. Really, really nice condition. Customer sent this in to have all the electrolytic capacitors replaced, transceiver alignment, and it had no transmit power. It looked like someone may have tried to troubleshoot it. I don't know. It had some work done. I don't really see that they really replaced anything. The parts don't look like they had been changed. I don't know what the heck they were doing. The actual problem was the wire had popped loose off of the coax connector. It was still apparently making enough contact where you could receive, the signal could basically jump the connector gap there, and you could still hear some receive, but yeah, transmit power, it was a bad connection. So, but yeah, there was actual broken trace on, actually that wasn't the final, that was the driver, which is that transistor way back there. Get over top of it so you can see it. So you have the driver and the final here. One of the traces was broken to one of the leads on this. So again, that would also have prevented the power from getting out. And both of the, because they're nylon screws or plastic screws that hold these transistors on, they're a little bit of a pain in the neck to service because you have to desolder the wires off the bottom of them, remove the mounting bracket, because the transistors are screwed to those aluminum heatsink mounting brackets, but the screw head is on the bottom side. The nuts are on the top. So yeah, but both of those nylon screws were broken off, so I've had to take that out and put new nylon screws and nuts on there. Yeah, you can even see there's like a melt mark here on the soldering. Somebody melted the corner of the relay. Yeah, like I say, don't really know what the heck they were doing. Maybe an attempt to find what was wrong, when all it was bad solder connection right there at the coax connector. I've also applied a little bit of thermal glue, so it's a heat transfer glue to this resistor, because this does get a little bit warm. And any time a resistor, high wattage resistor, is sitting that close to a piece of sheet metal, yeah, you might as well just put a little bit of that on there. That way you can dissipate that heat out of the radio. No need to keep it inside the radio. Good receiving radio, of course. Earlier radios, nice big crystal filters. Now this actually should have really good, there's really no skip coming in right now, but this should actually have very good receive, very quiet receive on sideband. And the reason I say that is, this is a rather narrow crystal filter. I know nowadays all the rage seems to be widebanding, hi-fi. Yeah, well, come on people, they're AM radios. You're going to get hi-fi out of something like that, of a CB, about as well as you're going to get hi-fi out of my left big toe. So, actually, the narrower the better, because when you go widebanding and hi-fiing and whatever you want to call it, you let in a little bit more audio, but you let in one hell of a lot more noise. And noise is something you don't want coming into your radio, because it's just going to end up coming out of your speaker and making the conversations you're trying to listen to unintelligible, because it's just so much background noise. So of course, you have to have some audio bandwidth, or you won't hear any, the person talking. But where in the heck is the manual for this thing? The owner's manual actually has the specs in it. Let's see here. What is the 6 dB point for this? Selectivity on SSB is 1.2 kilohertz at 6 dB, and then at 2.3 kilohertz it's 50 dB. So yeah, it's about a 1.2 kilohertz audio bandwidth on that. So Yeah, and I'm one of those people, when it comes to sideband crystal filters, I want the narrowest I can get and still have enough audio definition for, good, clear conversation. But like I say, the narrower you can keep that frequency range, actually the better it's going to sound, because that's the only thing you're listening to, is the person talking. You're not listening to a bunch of other crap. AM on this, actually, since I got the spec sheet out here, AM selectivity is 3 kilohertz at 6 dB and 10 kilohertz at 50 dB. So, of course, AM's always wider, because you have to remember, AM is double sideband with a carrier. But then there's actually the ceramic filter, that little gray guy right down there. There's the 455 filter. So the SSB is a 7.8 megahertz, so that's a very standard frequency for crystal filters in CB radios, actually for a lot of radios. But yeah, 7.8 megahertz, very popular. So, but there you go. Now, actually, this is a crystal synthesized, and actually, I need to actually show you all of that, because it's all, they call this a crystal oven. Literally, that's what they call it. Siltronix calls this a crystal oven. I don't know how it's a crystal oven, because there's no heating element. But that's what they call it. And no, that's not a heating element. That's actually part of the voltage regulator circuit for the actual radio coming in off the power cord. It's part of their, and this was an afterthought. That's why it's bodged into the oscillator circuit here. Depending when your radio was built, you may not have this circuit, because in the schematic, this is all attached with dotted lines, meaning that it may have it or it may not. Just like your radio may or may not have an SSB ALC circuit. It was in some radios, not in others. It's a lot of your earlier radios like this. They'd release something and then they'd come out with, we need to add a circuit in, and they'd add it in, and yeah, they'd find wherever they could stick it, and I guess that was a convenient place to put the error amp transistor and the regulator. But yeah, whatever, it works. But so you can see it is crystal synthesized. So yeah, lots of it makes the alignments on these take a lot longer, because you don't just have and this has a boatload of IF transformers. Yeah, this isn't like a modern radio where you got a couple for AM, couple for sideband, couple for transmit. Yeah, this thing, it's just covered down here all along the back side. And hell, there's 2 there, 1 there. So we would have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 tunable transformers and coils, it looks like. Somewhere around there. Yeah, it's over 30. And then on top of that, you have all of these ceramic trimmer capacitors, for adjusting the frequency of every single one of these crystals. And there's some more trimmer caps down here for your SSB carrier balance. Another one back here is actually part of the final tuning circuit. So yeah, you got your work cut out for you when you do an alignment on one of these. It's definitely not a 5-minute process, that's for sure. And to make matters even worse, the alignment procedures doesn't really have all of the alignment procedure in it. The schematic has all of the components on it, but there's a lot of key parts that they kind of seem to leave out of the actual alignment procedure itself, like the SSB ALC, AMC, and this actually has an AM ALC. Yeah, it's a weird setup, but it has AM AMC and also has an AM ALC. Now, actually, the AM ALC is more kind of the way they have it wired in. It's almost like a mic amp gain control. It's not really a reactive circuit, so yeah, it's almost more like a AM mic gain control. But so there you go. Like I say, it's been recapped, cleaned off, because oh man, this is one of those radios that they weren't shy of using soldering flux when they wave soldered this thing. So the bottom of this board, I mean, it's brown on top. It's a brown circuit board, but yeah, the bottom, the circuit side of this has green solder mask on it. Yeah, it was hard to see the green for all of the flux that was on there. So I got all, after I got done replacing all the electrolytic capacitors, got all that goop replaced. Actually, let me just get her flipped over here, show you the bottom side. Now this has, actually I need to put some screws back into this little guy. So our cover and part of the voltage regulator circuit don't go flopping around. Let's get one screw in it, be good enough. Oh, and that's another nice thing. The radio even has the original factory correct Siltronix microphone. But what was I getting ready to say? Oh, clarifier. The clarifier, or fine tuning on these. This was because this is an early radio, so it is unlocked on this already. Modern radios and radios not too long after this radio was produced, FCC changed regulations, and the transmit frequency and receive frequencies are separate. So if you have a delta tune, fine tune, clarifier, whatever you want to call it, when you turn that, you're only adjusting the receive frequency. Your transmit frequency is controlled from the inside. Popular modification, of course, is you unlock the clarifier. Early radios like this, you don't have to worry about that. The receive and transmit frequency are already locked because it wasn't regulated back then that they had to be, the transmit frequency could not be adjusted from the outside of the radio. So, and actually that makes it very nice for this because this is a sideband radio, and you got to remember, it's not PLL synthesized, it's crystal controlled. So if you get two crystals starting to drift off, yeah, you could end up with a completely useless radio. It's something like this that's crystal controlled. So what they actually have, it's not a potentiometer, it's actually a potato slicer, or air variable capacitor. Okay, so that's actually the signal there. Actually comes out through that wire. Yeah, they've got this coil crammed down in here, and I don't want to move that because if I go moving that, that's going to change its inductance, and that's going to actually throw the alignment off that I did. But when I actually went to do the alignment on this, I couldn't get any of the crystals to align properly. So what you do is you center the clarifier, so halfway rotation, or you're half meshed, and then you do your alignment of all the crystals. Every single one of them was off. I couldn't get them they were all off like 2 to 3 kilohertz, way out of tolerance. Again, not in the alignment procedure. They fail to tell you about this coil down here. This coil is in series with the fine-tune clarifier. And that actually will change the frequency as well. So that's actually all I had to do was do some adjustments here. I basically centered one of the, whatever channel I was on, I centered in the mixing scheme. I centered that variable trimmer capacitor in the center of its rotation, then adjusted this for the proper frequency, and then that brought the rest of the crystals into where they were within a tunable range using those variable trimmer caps. But so yep, early radios, you don't have to worry about unlocking clarifiers. It's already done, and usually your early radios, they have a delta tune clarifier. That's what you're going to find in there. It's not going to be a variable resistor, like a volume control. It's going to be an air variable cap like that. But yeah, so if you ever do work on one of these, now these are rare to start with, so odds are you won't. But if you ever do get one of these and you're doing an alignment on it, and you run into that problem where you're attaching to, there's a test point down here, and actually there's another one down, actually there's a bunch of them. There's another one there, another one back over here. But those are, you're going to be checking for your AM, your upper and lower sideband frequency adjustments. If you cannot get any of those into alignment. Now, it's not uncommon in an old radio to have several crystals go bad, and not bad to the point where they're not working. I just mean they've drifted out of tolerance, and you can no longer calibrate them using those trimmer capacitors. If every single one of them is off, and they're all off about the same amount, 1, 2, 3, 4 kilohertz, something like that, there's probably another problem. Either somebody's been tinkering with the radio, or there's something like this, where in this radio, it's on the schematic. It's not like they forgot to put it on there, so they have this coil on the schematic, they just fail to reference that in the alignment procedure. So, you know, look for stuff like this. So if you work on one of these and you run into that problem, none of your frequencies, you can't get any of them aligned properly. Just tune this coil. What I'd suggest is pick any of the adjustments. So, you know, whatever channel, if you're on channel 1 on TPA, and it tells you to adjust whichever the VR or VC, variable capacitor 300 and whatever. Put that trimmer capacitor in the center of its range. Your frequency is going to be way off if you're looking at your frequency counter. That's fine. But put that variable trimmer cap in the center of its range, and then adjust this adjustable coil here, and you'll tune that. Get it as close as you can to the center of the actual, you know, to the frequency you actually want, and then all of the crystals, because that'll shift the frequency for every single crystal. Because remember, that's attached to this. This is in circuit all the time, receive and transmit. So yeah, adjusting that will adjust the frequency of all of the crystals. Every single crystal inside that cage is affected by this coil right here. So adjusting this shifts that frequency of every single crystal in there. So just something to keep in mind if you happen to run into that problem. But yeah, so there's the underside. Like I said, cleaned up rather nice. Like I say, it was originally one of those brown goopy radios that had just half a gallon of flux residue left on it. Really nasty. So nice radios. I mean, nice heavy build. You know, aluminum, real aluminum. This isn't fake. It's not a little aluminum decal over that. All these pieces are, you know, they're solid aluminum. Faceplate, solid aluminum knobs. You know, other than the plastic inserts, the little trim inserts. But yeah, everything, you know, built a lot of quality. Now here's the kicker. In 1974, I actually looked this up in CB magazine. Went out and pulled some old my old CB magazines. I think it was a 1974 issue magazine. It was, you know, released in 1974, I think it was. Had an advertisement for this radio. $395. Yep. I hear people complain about, these radios cost too much nowadays. Oh, really? Well, here's a perfect example of you're talking out your ass. Because this radio cost $395 in 1974. I have not converted that over to current money, you know, accounting for inflation and everything. But I would have to guess that will probably put this radio, you know, accounting for inflation, this radio probably over $1,000 nowadays. So yeah, I hear people talk about, you know, the $200 or $300 radio. It's just too blasted much money. Yeah, well, radios back then, and people wonder why you'll often. Luckily, this radio cabinet's really nice condition. It doesn't have any holes drilled in it, but it's not uncommon. You'll find old radios like this with 2 or 4 gigantic holes drilled into the top cover. That's because it had one of those security locking brackets, and that's why people did it. These radios were a huge investment. You've saved up for months or even years. You know, you planned your radio purchases years in advance sometimes because they cost so much. This radio is no exception. Actually, the same time this was out, the Siltronix, you know, 1011 series radios were out. And that's the base station radio. Those were what were they, in 1974? They were like 540 or $550, somewhere around there. So, you know, this was considered extremely state-of-the-art, because this is an all-solid-state radio, no vacuum tube. So yeah, it fetched even, you know, considering the size compared to a Siltronix 1011, you know, this cost a lot of money. But yep, really nice radio. Really nice. The guy who owns this is a collector, likes the old classics. Like I say, it's nice. It covers in nice shape, has the original microphone with it, so I can get her put back together and boxed up with a gazillion microphones that I redid for him. He sent the mother load of Turners from +2s to +3s. God, what else do I got out there? Sidekicks, JM +2s, JM +3s, or the JM 2 +2-Us. Yeah, I mean, he had a box filled with Turner microphones. 1 or 2 of them actually got wired for this radio. But there you go. In case you never see one, now you can say you have the Siltronix SSB-23 transceiver.